Welcome to the deep dive. We take complex, often groundbreaking research, and we really try to distill it down to the core insights you need.
And today we're tackling something with huge implications.
Absolutely. We're diving into psychotic disorders, specifically schizophrenia. It's incredibly disabling, carries this enormous human and financial cost. And, well, finding ways to actually prevent it has felt like a really distant goal for a long, long time.
It really has. But the study we're looking at today, it kind of flips that idea on its head. It suggests a major opportunity for prevention might be, well, hiding in plain sight, right within our existing health services.
Hiding in plain sight. How so?
Get this. Almost half, 47% of all people diagnosed with a psychotic disorder in the general population had previously, often years before, attended adolescent psychiatry services.
Wait, 47%. That's staggering.
It is. It means these services, for kids aged around 13 to 17 dealing with various issues, they're unintentionally flagging a huge proportion of future cases.
So it creates this massive natural window for potential intervention years before a diagnosis.
Exactly. If we could find something that works for that specific group, the potential impact is just immense.
Okay, so what's the potential intervention here? This is the surprising part, isn't it?
It really is. It's doxycycline, just a common antibiotic.
Right, the kind you get for infections, or sometimes acne.
Precisely. And this massive study we're digging into used nationwide data from Finland, plus some really robust statistical methods, to suggest this everyday drug might actually causally reduce schizophrenia risk in precisely this high-risk adolescent group.
Okay, let's unpack that. First, tell us more about this high-risk group, the kids attending adolescent psychiatry services. How high is the risk, really?
Well, the study focused specifically on young people, 13 to 17, who attended these services, often for things like depression, anxiety, maybe behavioral problems, not necessarily showing early psychosis signs yet. And within that group, the risk is already significantly elevated. About 15% of them were diagnosed with a psychotic disorder by the time they reached age 28.
15%. That's much higher than the general population.
Much higher. But then, if you look at the subset within that group who had even one inpatient admission during adolescence, that risk jumps to an incredible 37% by age 28.
37%?
Oh,
Wow, so these services are clearly seeing the individuals who are most vulnerable long before the psychosis emerges.
they absolutely are. They're capturing a huge slice of the future cases, far more than, say, specialized clinical high-risk services managed to identify.
Okay, so we had this identified population. Now back to the intervention. Doxycycline. Why on earth would an antibiotic have any effect on psychosis risk?
Yeah, it sounds counterintuitive at first, but it's not really about its antibiotic properties. Doxycycline and a related drug minocycline are known to get into the brain easily high brain penetrance. And more importantly, lab studies, experimental models, show they have these neuroprotective effects. They act as anti-inflammatory agents, they modulate the immune system within the brain.
Right, I've heard about the inflammation hypothesis in psychosis research. But haven't people tried anti-inflammatories before, with mixed results?
They have. And crucially, those previous studies, some observational, some small trials, they mostly showed that doxycycline doesn't work for people who already have schizophrenia or who are in those late advanced prodromal stages just before diagnosis.
So it failed when given later.
Exactly. And that failure might actually be the key clue here. It strongly suggests that timing is absolutely critical. If this drug works by influencing some underlying neurobiological process, you have to give it much earlier.
Like during adolescence, when these young people are showing up in psychiatric services, but are still, as you said, sort of far upstream of a full psychosis diagnosis.
Precisely. That seems to be the window.
Okay, that makes sense. But studying this kind of long-term prevention is notoriously difficult, right? You can't easily do a standard randomized controlled trial, an RCT, for something like this.
Absolutely not. Imagine trying to recruit tens of thousands of teenagers, randomly assign them to take a drug or placebo for years, and then follow them for, say, 10 or 15 years until they're 30, just to see who develops psychosis. It's practically impossible. The cost, the logistics, the ethics.
So how did these researchers in Finland manage it? They used real-world data, but claimed something close to causal inference. How?
They did something clever. They didn't run a traditional RCT. They emulated one using nationwide health register data.
Emulated a trial.
Yeah. They took data on everyone born in Finland between 1987 and 1997 who attended adolescent psychiatry services and had used antibiotics at some point. The final sample size was huge, over 56,000 individuals.
Oh, okay, that's scale.
Definitely. And they followed these individuals from their first antibiotic prescription right up to age 30. So that covers the entire peak risk period for psychosis onset, avoiding a major limitation of smaller, shorter trials.
But just observing people doesn't prove cause and effect. People who take doxycycline might be different in other ways from people who don't. How do they handle that bias?
That's where the advanced methods come in. They used a statistical technique called the G formula. It's designed for exactly this kind of situation, using observational data to estimate what would have happened if everyone had followed a specific treatment plan, like taking doxycycline versus not.
The G formula sounds complex. What does it do, sort of in simple terms?
Well, think about all the things that change over 10 years. Someone's health might improve or decline. They might start or stop other medications. Their reasons for needing treatment change. These are time-varying confounders.
Right, things that muddy the waters.
Yeah, exactly. A simple analysis can't easily account for all that. The G formula allows researchers to sequentially adjust for these changing factors across the entire follow-up period. It simulates the randomization process over time, getting them much closer to a true causal estimate than typical observational methods allow.
Okay, that sounds quite sophisticated. And what about who they compare the doxycycline users to? You can't just compare them to people who took no antibiotics, right?
Correct. That would be a major flaw confounding by indication. People needing antibiotics might be different health-wise from those who don't. So they used what's called an active comparator design.
Meaning?
They compared the adolescents who received doxycycline to other adolescents in psychiatric services who received a different antibiotic, something like amoxicillin or penicillin, drugs not thought to have these specific neuroprotective effects.
Ah, I see. So you're comparing sick enough for an antibiotics versus sick enough for a different antibiotic.
Yeah.
That helps level the playing field.
Precisely. It helps isolate the potential non-antibiotic effects of doxycycline itself. Rather than just the effect of seeking treatment or having an infection, it's a much stronger design.
Okay, the methodology sounds incredibly robust for observational data. So the big question, what did they find? What were the results for that main group of over 52,000 adolescent psychiatry patients?
The results were pretty striking. In the group that received other antibiotics, the active comparator group, the risk of developing schizophrenia over 10 years was about 2.1%.
Okay, 2.1%. And for the doxycycline group?
For those treated with doxycycline, the risk was significantly lower. We're talking about a 30 to 35% lower risk of schizophrenia at that 10-year mark compared to the group getting other antibiotics.
30 to 35% reduction. That's huge for a condition like schizophrenia.
It's a very substantial potential effect size, yes, especially considering how common and accessible doxycycline is.
And what kind of dose are we talking about? Did people need to be on it for years, like for acne treatment?
Not necessarily, it seems. Only about 28%, so just over a quarter of the sample actually got doxycycline. And the median, the sort of typical cumulative dose, was only 1,500 milligrams.
1,500 milligrams. How much treatment is that, roughly?
Well, a common daily dose is 100 milligrams, so 1,500 milligrams corresponds to maybe a 15-day course, a relatively short treatment.
So even a fairly short exposure during that adolescent period seemed to be associated with this lasting reduction in risk.
That's what the data suggests. They did look at different dose levels. The group with higher cumulative doses, 3,000 milligrams or more, still showed about a 1/3 risk reduction compared to the comparator group. But even lower doses seemed protective.
That's fascinating. And what about that smaller, even higher risk group, the ones who had an inpatient stay during adolescence?
Yeah, the results were arguably even more dramatic there. For that subset, looking at the high-dose doxycycline group, the risk reduction at 15 years was around 50%. A risk ratio of 0.50 compared to the comparator group.
A 50% reduction in risk for the highest risk group. That's potentially transformative for those services.
Absolutely. It really highlights the potential impact if this effect is real and causal.
Okay, the implications are clearly massive.
Oh.
But let's circle back to the why. Why doxycycline? What's the proposed mechanism here? How does an antibiotic stop something as complex as schizophrenia developing?
The thinking ties back to those secondary effects, the immunomodulatory and anti-inflammatory properties. And the key biological process researchers are focusing on is something called synaptic pruning.
Synaptic pruning. It was the brain clearing out connections during development, right?
Exactly. It's a normal, necessary process during adolescence, sort of refining the brain's wiring. But the theory in schizophrenia is that this pruning process goes into overdrive, it becomes excessive, removing too many important connections.
Okay.
And the hypothesis is that doxycycline, through its anti-inflammatory and immune effects in the brain, might help to kind of dial back or normalize that excessive pruning process, preventing the damage before it happens.
And again, the timing is crucial because this pruning is happening intensely during adolescence, precisely when these young people are interacting with psychiatric services.
That seems to be the critical window. Trying to intervene later after the pruning might have already run its aberrant course seems to be less effective, which lines up with the failures of previous trials in adults or late prodromal states.
Makes sense. Did the researchers do anything else to check if this finding was real and not just some fluke or related to why people get doxycycline like acne?
They did. They ran several negative control analyses, which are important for building confidence. First, they checked factors related to acne treatment itself, severity, duration, and found those didn't explain the reduced schizophrenia risk.
Okay, so probably not just an acne effect.
Right. And then they tested a negative control outcome. They looked to see if doxycycline exposure was also associated with a lower risk of, say, anorexia nervosa, another serious condition that can emerge in adolescence.
And was it?
No. Doxycycline showed no protective effect against anorexia nervosa risk. This suggests the effect might be specific to the pathways involved in psychosis, not just some general health benefit conferred by the drug. That specificity really strengthens the finding.
Right. It makes it less likely to be just random noise or some broad, nonspecific effect.
Exactly.
So let's try to summarize this. We have a very large observational study using some of the most robust causal inference methods available short of a perfect RCT. And it suggests that a cheap, common, widely available antibiotic, doxycycline, given during adolescence to young people already in psychiatric care,
Might reduce their risk of developing schizophrenia later in life by a really significant amount, maybe 30 to 35%, even up to 50% in the highest risk groups.
It hinges on this idea of intervening early, potentially modulating immune processes or synaptic pruning during that critical developmental window.
Yes. And it really shifts the focus for prevention towards this population already identified within the healthcare system, rather than trying to screen the entire general population.
Now, we have to be clear. This is still observational data, even with fancy methods. It strongly suggests, causality, but doesn't definitively prove it like a large RCT would.
Absolutely. That's a crucial caveat. The study suggests doxycycline may causally reduce risk, and the evidence is compelling, but it's not final proof. But it certainly provides the strongest signal yet for a potential early pharmacological prevention strategy. It really puts anti-inflammatory or immune modulatory approaches firmly on the map for schizophrenia prevention research.
The implications for patients, families, healthcare systems, society, they're just enormous if this holds up.
Which brings us to the final thought for you, the listener.
Given this incredibly promising signal, the potential massive benefit, and the fact that doxycycline is already a well-understood, widely used drug,
What needs to happen next? What kind of definitive interventional research is now urgently required to confirm or refute these findings, perhaps in different populations or using different designs, to finally settle the question of causality and potentially turn this observation into a genuine global preventative strategy?